Hello everyone. This video hi linear momentum to impulse lecture bol de hintin. Previous three videos to center of mass abon ay bol sa witan na. To hi linear momentum to impulse bol de aban le khun next video aku rotational motion ay lut masang ba aku collision jang bol ngai na. Okay, so let's start. Linear momentum hi pikitina ha. So what is linear momentum? So linear momentum of a particle is defined as P equals to mv. Mass to product of mass to velocity chuna chichu momentum kiti cho. So here see system of particles are na. Particles so tam ta hunguma chun. Suppose you have n number of particles. The momentum of the system, okay, the momentum of the system cho pideha will be given by the sum of the individual momentum. Okay. The sum of the vector addition of the momentums of the individual particles. Na, so P total will be equals to, so P total it will be equals to summation of all the individual momentum. So P1 plus P2 plus P3 na, momentum to M into V is a M1 V1 plus M2 V2 plus M3 V3 plus it's a bonanan ko na, so you'll get the total momentum. Okay, or in short, you can write total momentum is equals to the total mass into velocity of center of mass. Okay, so here m is the total mass of the whole system. Mass zo si gom khom lao chen na, so total mass is a chilai v pa hi center of mass velocity cho che alang pia in general na, general momentum che pia momentum chu total mass into velocity of center of mass cho. Right, so the total momentum of system of particle is equals to the product of the total mass and the velocity of center of mass. Okay, so linear momentum basic na. So remember, linear momentum to be mass into velocity. Okay, that is linear momentum. Right, see, chila hi concept of conservation of linear momentum. He pa hi problem solving like haman so je he jo iti phale momentum ki conserve ji ha. Suppose external force acting on the system. Okay, if there are no external force acting on the system, or you can say external forces acting on the system adds up to 0. Okay, effect ima cham lo tina so external forces also na. So external forces effect ima cham lo wala chun. So the center of mass move with constant velocity. Okay, so here if the center of mass move with constant velocity, v to constant here la chun mass to constant chula na, momentum to m into v cho. So that means the momentum will be constant. Okay, momentum constant cho piha. Ab atila initial momentum na nei pa chu final as momentum ki bangna nei na ki hello de constant tina cho momentum cho. So that means the initial momentum will be equals to final momentum. So there will be no change in momentum throughout the whole motion. Chu piha, that is called conservation. Momentum is conserved na. So let's try to write see momentum cho piha, momentum total pa chu total mass into velocity of center of mass iti chu na chila hi. Atile see differentiate both sides. If I differentiate both sides, what will I have? So dpt total momentum divided by t. Differentiate with respect to time na. Mass constant is a so d by dt into so m into vcom. Okay. Chila hi mass hi constant ja so not all chun, so d by dt into vcom. Okay. Chipen hi biha dp by dt na. To with respect to time as we differentiate values in jing pot so chipen hi na. Ale chun tang Newton's second law so bita. According to Newton's second law, force to be kitita applied force pa cho rate of change of momentum kiti chuna chi. So that means the rate of change of momentum is the force. So which is nothing but so this one chipa hi force cho according to Newton's second law. Alechila hi force pa chu, see what is the force? Force is equals to mass into acceleration of center of mass. Chila ko na cho batang relation kharam kit cho. Ehon second law F equals to ma ti pa ho na chipen ko system of particles and apply no mala chun force cho piha. So force will be given by so the total mass into acceleration of center of mass. Okay. Chilai achunga batang achunga chilai na jita bang wahe na. So momentum cho piha mass into total mass into velocity of center of mass chule na. System of particles ading acho particle tam ta hum khom pale chuna. Chita bang acho force acting on the system of particle is equals to, so the force is equals to total mass into the acceleration of center of mass. Okay. To the actual definition for system of particles na F equals to ma pa ho. So here see F equals to dp by dt Newton's second law chule na. Suppose if the applied force, that means the external force. Okay, F is equals to 0. The applied force pa he 0 here chun ipiti re ha. Achunga equation pa ho. Equation number 1 ka tiu ta chunga ho. Equation number 1 pa he ti ha. So here you'll have, so 0 is equals to m into, so dvcom divided by dt. Veilang 0 ta chula na chila hi. Atil m ho veilang transfer la chun 0, 0 divided by anything is 0. So here you'll have, so finally vcom will also be not like this. So dvcom by dt, so this is equals to 0. Okay. It's possible ha. So when is this possible? When will you have dv by dt equals to 0? See, differentiation of any constant is 0 na. Calculus but suppose you have a function x equals to, so 2t square plus 3. Okay. If I want to differentiate this with respect to time, so dx by dt chupi ha. So 2 comparing to 2 or 4 plus 0 is usual na chala hi. Ibola 0 ham, so 3 ju constant za 3 ju ka differentiate ala chun 0 hang podet chine chu. Okay. So 3 is constant. If you differentiate any constant, you will get 0. Okay. So which means chila jang vela chun v here ki differentiate ala chun 0 hang pot ina chu chi. So this is possible only if, so vcom, so this is constant. Okay. Right, so the center of mass velocity is constant here. So if I differentiate that value, I will get 0. Okay, so that is possible when the external force, the applied force is 0 here. Okay, so when the external force is 0. Okay. Atile vcom pa constant here chun to chubita formula chupita. So p total chu, so mass into vcom chula na formula chu. Ale v pa hi bele chun chila hi chipa hi constant hi le chun mass jong chu constant chula na. Mass jong chu constant hi le chun abona constant chula. So which means, so p is also now constant. Okay, momentum is constant chula na. Momentum is constant hi le chun constant means it is not changing with time. Okay, atile initial momentum na nei pa chu, final momentum na nei pa chu ki bang tine chu. So therefore you'll have P initial equals to P final. So this is the concept of conservation of linear momentum. Okay. Atile ko hecho ga apply with question solve na. So first question. Internal forces can change. Option linear momentum but not kinetic energy. But you have to know one thing. Internal forces na. So it can change the energy possessed by the body. Okay. So one thing is you can change the kinetic energy here, but linear momentum paso ipina change the ha. So when will the linear momentum change? Applied force on palabo ki na. You know that F equals to what? dp by dt. So the momentum will change only if there is force. If this is not equals to 0. Okay. Force paso 0 here chun. So see. So if suppose here force is 0, so you have 0 equals to dp by dt. Okay. So here dt goes here 0 na. dp equals to 0. dp chu pitina change tine so d chu. So p final minus p initial equals to 0. So p final equals to p initial. It's if case ha. Force is 0 here. So this is a conservation of linear momentum. Na momentum ju can conserve sila. So here the momentum is not changing. Okay. Force 0 here. So momentum is not changing. But force, when the force is non-zero, okay, it is not equals to 0, the momentum will change. So impulse involved. So here if internal forces change, so here linear momentum will not be affected here. Okay. But the kinetic energy will change na. Internal forces can change linear kinetic energy but not linear momentum. Okay, so this is the answer. So remember, momentum changes only if, okay, so this changes if external force is there. Okay, F external is not equals to 0. Okay, next part. A body breaks at rest. Na rest tine. So rest breaks into two pieces of equal masses. So the part will move. Body ka jutai rest na ji. So let's say the mass is what 2m. Okay. Atila initially acho body chu rest intin hichipa hi finally it breaks into two equal parts adicho. Mass m to mass m ki break na. until okay break ahi let's say mass m khat pa hin velocity v1 anaya khat pa hin v2 anai do na alehin chila hi pitia see it breaks due to its own internal energy bata polang force zawa ke break lo cha chila hi so here the break is due to its own internal energy question na chuna ka sei lo chun polang ko na external force ki apply ja ki break a hi lo chun so every break a break zo se na examples of bomb pu ke ho jong ho so all of those are due to its own internal energy okay internal energy hello internal force ho ji achuna break a hi la chun so in this case you can conserve momentum okay force ho chu external a hi lo chun na momentum na conserve theu cha chala hi so if you conserve momentum here so p initial should be equals to p final na initial as a momentum p ham mass into velocity raise arm velocity to 0 na initial acho so this is equals to finally you have mass m into v1 plus mass m into v2 okay system of particles niyam malachon m1 v1 plus m2 v2 to total momentum na so I say the bama so particles thoma malachon m1 v1 plus m2 v2 plus m3 v3 like that okay and so on chila hisat ham so 0 equals to m1 v1 plus m2 v2 mv2 khari transfer lechon I will have m v1 equals to minus m v2 na gets cancelled out if you match v1 is equals to minus v2 so these are actually velocity okay I can put a bar here chichu pide na v1 to v2 hi opposite direction om tine chu chala minus pa hai na chi so here this minus indicates opposite okay so v1 and v2 are opposite and there is equal to sign here na equals to sign chichu if I take the magnitude mod length so mod of v1 is equals to mod of v2 magnitude ki bangtene chu chalai so their magnitudes are equal okay equal magnitude different direction na if you answer so in opposite direction with equal speeds okay that is the answer abana assertion reason question khat na when a firecracker a rocket explodes in mid-air its fragments fly in such a way that they continue to move along the same path which the firecracker would have followed had it not exploded. Examples na ita rocket ji so a rocket is going okay like this. A path to the center of mass path to ha. So it is straight. Let's say okay, this is the path of the center of mass. A rocket to poke na center of mass path na ita straight a chizing so jala a fragment hozo suzuki the thang so pozo so after it explodes here so all the fragments okay fragments will move in all random direction na suppose let's say m1 v1 goes here v2 goes here m2 right m3 so v3 goes in this direction direction fragment hacho length adi ta chala na so they will not move along the center of mass path so this is the path of center of mass okay it will continue to go straight evanga particles also it will go away from the center of mass okay they will continue to move in the same path in which the firecracker would have followed Japan center of mass path so this one is wrong okay but explosion of a cracker occurs due to internal forces only due to its own internal energy okay internal forces that is why it explodes so no external forces X for this explosion so this is correct okay Batang ITZ ahi question hung ke dongzi beta bomb khacha pu za za kho velocity chipa velocity zat ham khatpa velocity zat ham ti vela ke dongzi chuna so here it is due to internal forces only so which is why so here you can conserve momentum okay so momentum conservation is possible hita bomb pu ke question hong ke do phala chuna so there you can apply conservation of momentum okay aji chu piham explosion chu internal forces, internal energy so there are no external forces. Okay, but that is why you can apply conservation of momentum. Answer to PM A is not correct, so R is correct. A stationary particle breaks into two parts of mass, MA and MB, which moves with VA and VB. So the ratio of their kinetic energy is. So particle breaks into two parts. See, question you have to assume that there are no external forces here, okay? So which means you can conserve momentum here, na? Initial momentum equals to final momentum. Initially as you combine hisa na, combine hunza MA plus MB combine aom hisa, ahi vanga chu address cho initially cho. So now they breaks down MA chipahe VA chintin plus MB into VB. Na ita he. Atile left lang chu 0 hisa. Khatpa he in transfer lechun MA VA should be equals to minus MB VB. Okay, magnitude magnitude of momentum. So mode of MAVA should be equals to mode of MBVB. As you energy who scalar quantity chulana, chilai who direction ngai chalo cho, chilai bola minus of hamtile VA to VB he opposite are length ni cho. Okay, energy holding also magnitude both say ngai chana chilai he. Atile ratio of their kinetic energy ticho KB divided by KA. Chicho piha. Half into MB into VB square divided by half into MA into VA square. Na chicho. Chilai pa because half cancel out. So I can write MB VB, okay, into VB, MA VA into VA. Chilai pitia. MB VB chiten cancel na chicho achunga hai bata achunga hai. So it says that they are equal, okay. Magnitude part na equal hisa chu ki cancellation remaining to pm VB divided by VA. So ratio to pd VB is to VA. Okay. Option nacho. So option 1. Okay. So here you make a correction. VB is to VA. Okay. Option ju is equal. So okay. Banacho. Two bodies of mass 4 gram to 25 grams are moving with equal kinetic energy. Okay. Velocity chu ki hello na khachu U1 tutin khachu U2 tute. Question also KP to PM kinetic energy ki bang na. So let's say K1 is equals to K2. Khatpa to half into mass to 4 into U1 square should be equals to half into mass to 25 into U2 square. So half gets cancelled out. U1 by U2 squares is at the So I will have here 25 by 4. Okay. Both sides square root la lang U1 by U2 chu zarang po diham. So 25 ko 5 square na 4 ko 2 square. Chilai ko na U1 by U2 ratio am ta so. Ale ratio of their momentum ki dong na question na cho. So therefore you do the ratio. So P1 divided by P2. So P1 to piham M1 into V1 U1. P2 to M2 into U2 na. Mass to that 4 grams. Okay, 4 gram into U1 M1 by M2 into U1 by U2. Na value pollution 4 divided by 25 into U1 by U2 5 divided by 2. So cancel out 2 are 4, 5 are 25. So 2 divided by 5. Na a ratio on 2 is to 5 So option C. Okay, next question. A body of mass 1000 kg is moving horizontally with velocity 6 meter per second. So if 200 kg extra is added, then the final velocity will be. Matang jela hi 200 kg mass ki a force ki apply cho milo na jela hi. So here initially you have 1000 kg. Chipa hi 6 meter per second achi na jela hi. Ale chom khazawa hi mass ki habia chon mass ho jata. So 12 1000 plus 200 ki habia na ji. So which means how much 1200 kg new mass chana. Speed chu ki hello cha jela hi. Momentum direct conserve le chon. So P initial equals to P final. So 1000 into 6, right, should be equals to, so 1200 into V. Is that the answer here? So V is 1000 into 6 divided by 12. 1200. So 0 cancel out. 6 2 are 12. So 2 5 are 10. So V will be 5 meter per second. Okay. So answer is D. So next you have an artillery piece of mass M fires a shell. Artillery kiticho may na. You can also say that it is a gun. Okay. So you have a gun. I'll simply draw something here. Okay, let's say this is a gun, artillery. Artillery mass ipiham mass M1 na chi. Atila chuvata ake fire masanga so bullet mass so the bullet is also here. Okay. So let's say the bullet is mass m2. Bullet jong changlo, artillery jong changlo na initial acho ke fire masanga cho. So after firing, so what will happen? Artillery to m1 is a bullet to leng dot acho chala. So now the bullet is flying outside. Speed of bullet na v2 tiute. Mass to m2 na je. So here instantaneously after firing, the ratio of the kinetic energy of the artillery to that of the cell. Betang recoil velocity kiti khan beta. Mai thal khoi kap phal khon achang leng in ten mai thal pa khon annung sot chuna. So here m1 will be along the side v1. Okay, so what is v1? So this is the recoil velocity. Okay, we call this recoil velocity. Khat pa hi muzzle velocity yung kiti beta japan hi. Sometimes it is called muzzle velocity, muzzle speed na. Okay, so here tang mai thal ki ka phal son external force i lo pichula na sunga internal energy is so internal force achu bullets ki kap do so. So therefore here also you can conserve momentum. Okay, momentum conserve lesson. So p initial equals to p final. Initial achu pm m1 plus m2 khom na a hi wanga chu chang lo chu address. Okay, finally m1 into betang recoil velocity to opposite achi chuna. So v1 is opposite, so minus v1. So plus m2 into v2. So from here you'll have m1 v1 equals to m2 v2. Question khon pi do am the ratio of their kinetic energy ati cho. So here what is m1 by m2? So m1 by m2 is v2 divided by v1. Okay, so let's say equation number 1. As cho kinetic energy ratio whole ngai na. So here see you can also write here v1 by v2 equals to m2 by m1. As question ahe na. Question ahe chalai option he valuation m1 m2 yan sang ki pichula na. Question they can also give you in terms of v1 and v2. Okay, right? So in that case you may use any one of this one. The ratio to artillery is to cell adozula na. So therefore k1 by k2. So which is what? Half into m1 into v1 square divided by half into m2 into v2 square. So half cancel out. Option ahi m1 m2 nga changa amji achu. So we have to convert velocity into mass. Okay, so I will have here m1 by m2, right, into so v1 by v2 whole square, right? How much is this? M1 by m2 into v1 by v2 who is that? Japan here. So m2 by m1 na m2 square divided by m1 square. So here m2 gets cancelled out, m1 gets cancelled out. So finally you have m2 divided by m1. Okay, answer to PM option B. Bana, a ball of mass 50 grams is moving with speed 2 meter per second, strikes a surface at an angle 45 degree. Okay, to a hisi conservation of momentum in 2D. Okay, 2-dimensional ball. As a ball is 1-dimensional straight line. A ball is reflected by a plane at an equal angle of reflection with the same speed. So calculate the magnitude of change in momentum. The change. Okay, it is the same question. The change in momentum kitang so chala hai. But it is like this. So I have a hitting the wall ground at time so na chala hai. So plane surface is here. So here I'll try to draw hitahi ball hong cho tahi nung chikit na tahi atile chi direction pa hi tahi nga tahi chi na initial speed to be 2 meter per second ahong cho chi 2 meter per second ball khat na tahi chi 50 gram 2 meter per second at chuntin ground tochon plane surface tochon ki kolaga bana chu 2 meter per second mama chu ta ki reflect na abana angle jong chu ki bang ki pi chu na chala hi 45 degree at chu abana chu 45 degree mama chu ki rebound kit na reflect kit ala chala hi question chu pam change in momentum. Okay, chala hi so they can also ask you impulse. Okay, chala hi change in momentum bawol momentum conservation of momentum itiki apply am na to the acho chala hi you have to consider two different situation. Okay, so first is just before collision plane surface chon aki collide masang chara chona. So here just before collision if you look at the ball, So you will see that the velocity path so hirang chuna chipen. So this is the initial velocity, okay? U tube the initial path so initial path hi x to y ki split thai chu chala hi. I'm going to split this along this one uy to x langa chu ux. Okay, u chu tu hi la chun angle chu piha chipen hi 45 degree hi ngai na. So uy chu piham 2 cos 45 heading ux chu piham 2 sin 45 hongi ta chala hi. Sin 45 to 1 by root 2. So you will have here root 2 meter per second. Na, chila jong hi same 2 by root 2 to root 2 meter per second. Ux jong root 2, uy jong root 2 na chila hi. Chichu just before collision. So P initial momentum initial hold on nga chu chite ni ngai cha na. Ale after collision achu I can split this again. Chipa hi after collision chi. Chipa hi component chila khat chiding khat chila component chidina. Before collision achu chi hi chipa hi v is a so one component along this side another component along this side, okay? Two in component khala lawchun after acho. So here I will have here 2 sin 45 na chipen hi piha chipen hi v y tiute, okay? Abale x langa chu vx na vx chu piham so 2 sin 45 na vy hu 2 cos 45 kibang chuna chipen hi. So this is what again root 2. So 2 sin 45 is again root 2. To hi velocity component tam tam chuna na chi ti bol de ha. Batang momentum conservation ke ti na. You either have to conserve along the x, okay, or you have to conserve along the y. Chu pi de na ha. So conservation momentum p initial along the x should be equals to p final along the x, okay? Hita hi along the x a conservation ki bol thai a hi lo le y langa chu p initial along the y should be equals to p final along the y. Hita hi conservation in bol ngai chu, okay? Ale to hi change in momentum atiu chu na. So that means change is what p final minus p initial, okay? So here along the x bol ma saute along x axis change in momentum chu piha. So delta p chu piham so p final minus p initial na. So p final x minus p initial x tiute, okay? Chu piha mass into velocity chula na. So mass into final chu ux, okay? Vx zo na final chu vx along the x axis chu chipen hi. But along the axis chu chipen hi final velocity chipen hi initial velocity, okay? Along the y chu vy to uy na along the y after collision to vy is a before collision to uy na chila hi. Tun otile chipen hi minus m into ux, okay? Chu za de ha. So both of them are along the positive x-axis, right? So I will have here m into root 2. So plus minus m into root 2. So here you will have 0. Okay. Change in momentum along the x-axis is 0. Along the y-axis lale. Along y-axis. Along y-axis achu. So delta p change in momentum along the y-axis. Okay. Also along the x-axis. So piham p final along the y-axis minus p initial along the y-axis. Na, is that hachicho m into v final minus m into v initial. Chisuza ang podo diham. So m into v final ho vy ho piham root 2 na minus m into initial pa ho is that ha m into uy na. Batang uy ho piha. Negative lang ko na Japan here minus root 2 tinaso Japan here. So here along with the sign if you put it here you'll have minus root 2. So therefore m into minus root 2. Chicho piham minus minus so plus na. So you'll have 2 root 2 into m, okay? Mass value ko po lelchon. So 2 root 2 into 50 divided by 1000. Na chi here. Zarang po do diha. So 5 20 10. So root 2 to 1.4 divided by 10. So which means 0.14 kg meter per second. Okay. Change in momentum so na along the y so. Okay. Chilaya 2D collision 2D momentum conservation ba hai na. Collision involve phalo oblique collision involve phalo chilai ithasi ithavet ki diu cho. So here we will not do much. Okay, so we apply more of this to the momentum conservation in collision part. Now oblique collision part. Okay, next question. A cell of mass m is initially at rest. Okay, it explodes. Okay, explodes. Explodes is a bangma is a mabangma chu due to internal force. I hisa chu chalai momentum conservation hita chu chalai. So in the ratio of 2:2:1, if the fragments have equal masses, fragments having equal masses fly mutually perpendicular direction with speed v, the speed of the third lighter fragment will be. Let's see, I have a cell mass m. Okay. So atila chu address na velocity 0 chipa hyong ke explode ding din. So pieces ke bangten chu is that ha. So 2m by 5 na chipa 2m by 5 to khat chu 2m by 5 hi ngai na chala hi. Chiten hi perpendicular achi ke ti chu chala hi. So goes like this. Speed v perpendicular achi na. Khat pa chu chala nga hi, let's say along the side, let's say mass m by 5 na. M by 5. Velocity chu v dash tiu okay hello chu chi. Ibola 2m by 5 m by 5 belau ha. Amo si gom le chun m po de chu chala hi. Aha, basically na fraction na dilo wala chun chala m here lai 5m na la thai cho. If you take this as 5m, so here you'll have 2m, so here you'll have 2m, so here you'll have m. So calculations becomes much easier, okay? Kasi bang sa momentum chu along the x along the y conserve ngai na. So here let's try to conserve momentum along the x only, okay? So that means along this axis. So this is the y and this is the x. Okay. Alahin value chun x langa hi ppm. So first I have m pa hai na m by 5 pa hi value chun along the x. It is neither along x nor y, right? I have to take component. So component value chun is at ha. So along the side I have v dash perpendicular chun na 45. Okay. So v dash cos 45. Velocity component. Okay, along the side I have v dash sin 45 hi wang chu momentum x langa I conserve diu ja chu y lang chu ji ngai lo na. So here I will have, so p initial equals to p final along the x. Momentum conservation along the x, okay? So mass atila chu m hu za I wang chu rest sa na 0. So this is equals to m by 5 into velocity ho pi ha minus v dash cos 45. Okay, plus 2m by 5 into, so v. Okay. 2m by 5 pa ho z lang positive x lang china, therefore the velocity is v. So m by 5 pa hi negative x axis lang china, so therefore minus v dash cos 45. Okay. So you transfer it, you have m into v dash by 5 into root 2. Cos 45 is 1 by root 2 chula na. So this is equals to 2m into v divided by 5. Gets cancelled out. So 5 gets cancelled out. V dash is ang podam 2 root 2 meter per second. Okay. So answer is C. Okay, so now we are coming into impulse part na. Matang impulse kati pidi na ha. So a very large force which is applied for a very short amount of time. Na example to ball ka pelechon. Okay, suppose when you kick a ball, you're applying a large amount of force, but for a very short amount of time, right, on the ball. Okay, chiyo tabang force also impulsive force kiti na. So here I see large forces acting for a short duration of time. So these are called impulsive forces. Impulse by definition it is equals to the change in momentum. Okay, so impulse is the change in momentum. Impulse is equals to change in momentum. Right? So according to Newton's second law, so the rate of change of momentum so PM applied force chula na. So F is equals to dP by dt. Azo lang azong iman tao chula na si. 2 in dt pi chala transfer lechon. So you will have dP equals to F into dt. So integrate both side. Integrate both side bolechon. So you will have a dP integration F dt, right? So sipan here piha. So here integral. So P initial to P final. So dP. So dP integration to what? You will have P, right? Integrate dP, you will have P. So P initial, P final. So value put legend P final minus P initial hang po din na chi. So you have a relation, okay? So the change in momentum. So this side, left side heavy legend, sila nga hi change in momentum. momentum na chi left langa he z langa he value so integral f dt chi jong hi impulse ki ti cho chi impulse khud dan chuna you can also calculate impulse by the change in momentum or integrate f into dt ani nia hi impulse nan pi diu cho chi la he okay so based on that formula chalai formula pa kuna he na graph question ki dong thai so graph question chu tabang ham matang a relation chu pi ta a relation chu so here see force is equals to dp by dt chi newton second law na kharpen chu impulse chu pi ha impulse chu integral f into dt na chi he ka sai chu integration fx into dx so what is this integration to area ka di chula na so here in an f versus time graph so impulse will be given by the area under the curve okay so in a force versus time graph the impulse is given by area under the curve ay lo chalai ko na hi bata in a p versus time graph okay momentum versus time graph dp by dt chu differentiation ki ti na chu na chu pi ha slope ti na chu okay basic maths slope to area he bol ho na so those things okay so dp by dt chu pm tela this is a differentiation which is basically slope okay integration means area na so p versus momentum versus time impulse is given by the slope of the curve okay so let's solve some more questions here first question 2 a cricket ball of mass 150 gram is moving with velocity to 12 meter per second so it hit a bat the ball is turn back with velocity 20 meter per second if the duration of contact between the ball time kipina time hi value chana 0.01 second which is very small okay so find the impulse ado chula impulse so pi ha the change in momentum na apana average force ado okay chula na average force chu azowa formula man jo phala so here see kazo ka si ba ball ipi pera khuna so force lita ki apply only for short amount of time right so those type of forces are called impulsive forces okay chilai jong hi video chun cricket ball hi hitai bat on ti chi bat ti na japan so this is the bat so the cricket ball is flying towards the bat is that have velocity chu so 12 meter per second initially na abana bat to ki kolai da ki kolai jawa chu ki rebound kit na so now this gets rebound with how much 20 meter per second okay like this so initial momentum chu zat ha p initial so m initial into v initial na chi he chu zat ham mass chu 150 by 1000 into initial khu minus 12 towards the left side okay so minus 12 velocity chu chalai pen he abana final so pm p final equals to mass final bola mass initial kazi mass is always the same okay so mass into v final so here how much is this 150 by 1000 into so final to 20 nah 20 pen difference bol chun so what is impulse impulse is the change in momentum so p final minus p initial so 150 by 1000 okay so that means 20 minus 12 okay chito hinchi minus bol chun common chu chi chula na common chu kala ro jo polanga common pola kala do chun remaining chu pi ha 20 minus 12 solve lessons are put them so 150 divided by 1000 into so 32 okay you solve this one 0 gets cancelled out so how much is this for 8 are 32 for 2 are 8 for 5 are 20 5 3 are 15 5 5 are 25 so 3 8 are 24 divided by 5 na 5 4 are 20 5 8 are 40 impulse to newtons second impulse ki muta na to la chu abana chu average force ki dong chula na chi batang impulse see here delta p the change in momentum is equals to impulse to integral f dt chula na so here if the force is constant so here I can write average force f average into t okay or delta p equals to delta f into t okay chilai force by average na so therefore what is the average force is delta p divided by time change in momentum divided by time to force change in momentum se jan hong pora jo 4.8 hong pon na divided by time to 0.01. If you solve this, you'll get 480 Newton. Okay, average force to na. Okay, habana. A spherical body of mass 100 gram is dropped from a height of 10 meter. So ground apara 10 meter sang apara hi. Hunki drop to ball khat na chi. So spherical body. So this is what 500 gram. Okay. Aki drop ala chun tool chu zo na tool chu akhu tool chu akhu piha. Tool chu heading in den abana ki rebound ki chula na so cricket ball ki hen ta banga cho. So here there is an impulsive force exerted on the ground. Okay. Ale ground athuna hi a velocity is at them. Kinematics I ball lai so root 2 gh, right? Okay, so here you can apply conservation of energy and solve it. So initially you have mgh, okay? So ground athuna half mv square, na? So mass cancel out. V is at 2gh, root over 2gh. Okay, just remember the formula. Atila chu zat ham 2 into z2. Okay, value option ko kipi ko value chun point ngan chang chula na. So the value looks difficult. Okay, here I think they take a ZS 9.8. Okay, actually, if question also 10 kp na, let's take 10. So into height to 10. So how much is this? So here I will have 10 root 2 meter per second. 2 la chu achu na. Ala chun akiri bound kit achu ipidia. So do you think the velocity will be same? Hechi collision pa hi elastic hilo. So chala 2 la chu ako na. Collision involve pala elastic, non-elastic ball dio. Some energy is lost here. Okay, so 10 root 2 chu ala chun. So 10 root 2 ma chu kaltok ke di hilo chu chala hi. So it will go up with some velocity, let's say v. Okay, hechi v achu lien to jo huila chan kalhung ke da. So now height of 5 meters and kalhung ke chula na chala hi. Galeng to ke da 5 meters and chikitso. So here also you can apply conservation of energy. Half mv square equals to mgh na. H to 5. Therefore, what is v? V is equals to 2gh. Again, same formula. After collision also piham. So v2, so root over 2gh. Chuchu piha 2 into 10 into 5. So which is 10 meter per second na chila he. Question sa pidom impulse pia change in momentum, right? Velocity is just a sign of na. So this is going downward, so minus you can put it. Okay, velocity is just na. So what is the change in momentum? So we know that impulse is what? Impulse is the change in momentum. So P final minus P initial. So which is M into V final. Kharpa hi U lao to masapa hi ani nya V kita thelo. So masapa hi U lao te. Ani na pa ko V lao te na. So therefore I will have here MV minus M into U. So therefore M into V minus U. Is that a padam chila hi mass to 100 gram divided by 1000 kg convert na chila hi. So final ko 10 minus of minus 10 root 2. Solve it also. So divided by 10. So 10 plus 10 root 2. So 10 common 1 plus root 2 divided by 10. 10 cancel out. So you will have here 1 plus root 2 who is at 1.4 something, right? So I will take here 1.4. So the answer is 2.4 kg meter per second. Option lako kenai pipen hui ha 2.39 to kenai pen na. So the answer is 2.39. Okay. So impulse is basically the change in momentum. Okay, final minus initial. Chihi JEE Mains 2024 na. But tu chung NEET exam achu, so you will see one exact question like this. Okay, kibang chat. Okay, I'll show you. See, this is 2025 NEET exam. Okay, question is similar chun. So 0.5 kg is dropped from height of 40. Height value ke khial chula na, but the question is exactly the same thing. Okay, so it rises again till height 10 meter. So what is the impulse? Okay, na pima sitin question chung. So this is the reason. Okay, medical exam ading ke prepare na hiu le. So you have to solve the previous 2-3 JEE Mains questions. Okay, compulsory. Tu mang chi ana solve kha hi lo ana solve kha sa hi le hiu le chun. Ta chi question solve na so halo pia. You can answer this in right 30 seconds. Okay. Okay, so let's do it. Same question. So height to that kpm 40 meter raum na. Chilai ko na hi ball to 0.5 kg ki drop chu chi. Aki drop ala chun 2 la thuna cho velocity is a ham u equals to root over 2gh. Put the values 2 into 10 into height to 40. So how much is this? For 2 are 8. So 20 root 2 meter per second. Nui lang a chija cho minus ka put de chala hi. Okay. Now after that it rebounds with speed v. Huila chan kalhung kidam chipen hi 10 meter chan kalhung kid na chala hi. Ati la chun final velocity chun chu 2gh mamma ka apply ala chun 2 into 10 into height to 10 na chi hi. So here how much is this? This is 10 root 2 meter per second. Final velocity initial velocity So what is the impulse? So therefore impulse is equals to change in momentum. So P final minus P initial na chi. So M into V minus M into U. So M into V minus U. Is that they have mass to 0.5 na 0.5 to 1 by 2 tine into final ko 10 root 2. So minus of minus 20 root 2. Solve 1000 ang po diha sila here. So here if you solve, so 1 by 2 into, so 10 root 2 plus 20 root 2. Okay. So 1 by 2 into, so 10 plus 20 to 30 root 2. Right? So this gets cancelled out. I have 15. So 15 into root 2 to 1.4. Okay. So if you solve this, how much will you have? So here you'll get 21. Okay. 21 impulse na kg meter per second. Okay. Option la 21 jong umsa chala option ka je miltan na. You just go and check the question, okay, from the internet. So the answer is 21 impulse. Abola cheveta. So it is exactly the same na ke bangsa chula jete question here. Okay. So finally let's do two graph questions. So a very simple graph question. Masapen cho force versus time graph ke pi ala chun impulse to ki holde ha. So if you have force versus time graph, what is impulse? Area under the curve, right? So here area under the curve A upon B upon C ka chilsun area cho piha. So it is a triangle. Okay. So what is the height of this triangle? So this is given as 18000. So what is the width? Base to that 1.5. Now 2.5 minus 1 to the 1.5. So therefore what is the impulse? Impulse is the area under the curve. That means half into base into 1.5. Now 1.5 or 3 by 2 into 18,000. Solve this. So 2 into 900. 2 into 4500. So 3 5 are 15. 3 4 are 12. 13. 1350. Chipani impulse. Kg meter per second. Okay, simple direct area. Na force versus time graph KPI impulse to area under the curve. So next question, you have a graph again, momentum versus time. Force ke dong na the magnitude of force is maximum and minimum at also. Force of piham dp by dt. Chuchu pidinam slope dinacho. Slope is what? Tan theta. Okay, tan theta depends on theta, right? So here you see first part A part hibata chihi theta 1. So second part chihi theta 2. Third part chihi theta 3. So from here I can see that theta 3 is the greatest. And then I have theta 1 and then I have theta 2. Okay. That means the same way tan theta 3 is greatest. Tan theta 1 abana to tan theta 2. Slope to piham slope to tan theta na. So abana tan theta slope to piham force pa slope to na sila here. So that means F3 is the greatest. Okay. And then you have F1 and F2 is the least. Slope niya penso na. So here batang adita cho chipen hin negative value po so 10 na whole wala chun. But here they are talking about the magnitude. Okay. Theta li chara cho 10 values only in so. Okay. So what is the answer? Maximum to hilayama. So 3 now. 3 now is here C. C. This is the maximum. Abana minimum to hilayam 2 na. So B is the minimum. Okay. So C is the maximum, B is the minimum. Answer is D. Okay, then much impulse to momentum conservation na situation din. Next video palakun collision hoi boldu. So I hope you understand what we have learned today. I'll see you in the next video. Okay, so thank you.